let's do Leetcode number 20, valid parentheses. So we're given a string S containing these parenthesis characters, and we need to determine if the string S is valid. And it's valid if every open bracket is closed by the same type of bracket, they have to be closed in the right order, and they have to have a one-to-one correspondence. So we see some examples of ones that work, where you see an open and closed bracket, and they're in the right order, and then one that doesn't work, which is just two brackets that don't correspond to each other. We can think of a couple more examples, like this one right here with two parentheses. This one is valid because this parenthesis and this parenthesis cancel each other out, and then these two also cancel each other out. So you can kind of tell just how I phrase the problem, how we might approach the solution. So if we were to just decide if a string was valid by ourselves, how would we do it? We would start by reading left to right with this open parenthesis here, and we'd probably keep track in our mind of what the last open parenthesis was. So we know that it's a parenthesis type. So then we go on to the next thing we see, which is a closing bracket. So at this point, we need to determine if there was an opening bracket to correspond with it. And so we'd go back to what we saw, an opening bracket, and we just kind of cross these out, like these are okay. And once we see that those parentheses kind of cancel each other out, we can move on to this open bracket. We see that it has a closing bracket, so we can cross those out. And same with these. We see an opening followed by a closing, and we cross those. So what we're doing is keeping track of whatever the first opening bracket was, and that's going to be the last one we want out. So if you're thinking first in, last out, the data structure for that is a stack. So our first approach here is what we're going to call the stack approach. So in the stack approach, we're going to keep track of all the opening brackets we see, and we're going to want to know the most recent one, and we're going to pop them off when we see closing brackets. So we're going to check for two things. We're going to check if the brackets correspond as we pop them off. So let's do it with a real example, right? So here we're going to check, and this example doesn't work, as we can see. We're going to have these two opening brackets in this order, and we're going to pop off as we see this one. We're going to pop this kind of square bracket and see that it doesn't match up with this one and return false right here. The other thing we need to check for is if there's any open brackets at the end of after we've gone through this, then we know that it couldn't be valid because there's not a closing bracket for every corresponding open bracket. So the time and space complexity is going to be linear O of n for both. We're going to be able to do it just through one pass of the string, just keeping track of the stack. And in the worst case, the stack is going to contain every character in the string. Let's say if the string was all open or closed brackets. So this stack approach is pretty intuitive and is pretty good in terms of time and space complexity, but there's actually an O of 1 space complexity approach that we're going to go through at the end of the video. So you can skip ahead or stick around to see how we take on that challenge. Okay, so let's code up the stack approach. One thing we're going to need is a stack, so we can start with that. The other thing we're going to need is some way to determine if the brackets match up with each other. So we need to know kind of if brackets are of the same type. So one thing we can use is just a straight up dictionary. I'm going to call it brackets dict, and we're going to keep track of every type of parenthesis. So we actually have to be careful here with the decision. We're going to want to make the keys the closing parenthesis, because finding closing parentheses is what's going to trigger us to pop off the stack. That's what's we need to think, oh, what was the last open bracket we saw, and do they match up? Let's make the keys the closing side of the brackets. The instructions also mention that the characters are only going to be these special bracket characters, so the question makes it easy on us in terms of checking for invalid inputs. Now we can just start going through every character in the string. And we can just start off by checking if character is in brackets dict. So remember, in Python, checking if something is in a dictionary means you're checking the keys. So we're saying if the character is one of these three closing parentheses, then what do we want to do? Well, first off, we want to check if there's a stack there, at all. If the stack is empty, first up, we have to worry about an error of trying to access, an empty array. So if there is something in the stack, we can, pop that off. That's going to be our opening bracket. We want to check if the open bracket is the same as the bracket dictionary for character. So character is going to get the, whatever opening bracket is, and we want to check with the actual open bracket, like the most recent. we could skip this middleman here and just say stack.pop. That might be, a more intuitive way of thinking about it. And if that is the case, then, we're good to go. But if not, then we can just straight up return false immediately. Same with if there wasn't a stack to begin with. So if you find a closing bracket and there is no opening bracket, then we know that something's gone horribly wrong and we can return false there. Maybe for the sake of cleaner code, we can say if this is not the case, if the last opening bracket is not the same as this closing bracket we found, then we can just return false and skip ourselves an else statement. So here, if we didn't find a closing bracket, then we know that we found an opening one, and we just want to do stack.append whatever character it was. So then at the end, we can just return whether or not there is anything left in the stack. So if the length of stack is equal to 0, that means that every bracket was accounted for correctly and there's no opening brackets left over. And you can see that gets accepted. If you're really feeling fancy, you can just say if not stack, and we'll see if this works. Yeah, so that's the stack approach. So that's probably the most common way of approaching the problem, and a pretty good approach to take in interviews. But there's actually a better way for space complexity that we can look at. So maybe you've noticed that we're kind of working in terms of pairs of opening and closing brackets. What we can actually do is just use Python and replace every pair of bracket until we get to either an empty string or some, a collection of just opening or closing brackets, and return from there. So this solution will actually, it'll look really clean in terms of code, and we don't have to create like a stack variable and hold any data. So we can just modify the input string in place and get a constant space complexity. So I think this would be a pretty cool solution to whip out on your interviewer. So let's look at what the code looks like for this replacement approach. So we start with just the string s, and we're going to replace a pair of parentheses with just nothing, which is the same as kind of just removing it from the string. And we want to do this for every kind of pair of brackets here. But we can't just do it one time because they could be nested within each other, like an example like this one. So this is valid, but at first, there's only actually one pair of these next to each other. But as we remove them, you can see that other pairs kind of fall into place. And then at the end, there's nothing left. So we do need a for loop to do this a certain amount of times. We can just use the length of the string kind of as a number. And remember that replace is going to return a value, so we actually need to save it as s. And then the way we return our answer is similar to last time, so we just return length of s equals 0. So if the length of s is 0, there's nothing left. It means everything either found a pair, there's no kind of loose opening or closing brackets. And let's see if this works. So you can see that this 5-line solution actually works, which I think is pretty neat. But if you really think about it, you might have noticed that this is kind of arbitrary, the number of repetitions in this loop we're going through. And actually, for every pair of these, if the length of, like this length is 6, right? But there's actually 3 pairs. So the maximum amount of times we need to go through it is actually just half of the length of s. So this will cut down, not in worst case complexity, but it'll cut down kind of average. And this is probably as fast and as efficient in terms of space as the solution gets. So the solution actually isn't as fast as the last one just because of the way replace works. It's probably O of n each time we're doing this, but it's still going to reduce down to linear time complexity, and the space complexity is definitely better. So this is a cool solution to have in your back pocket going into an interview. But yeah, I hope you found this helpful, and if you did, like and subscribe, and I'll see you in the next one.